Here we are asked how many different sequences can be formed by using all the letters in the given word. So sequences is the key part. This is going to be a permutation because it's a sequence. Order is important. However, when we look over the words, we using all the letters given. So we count the number. Let's do A first, I guess is what I should say. Is so we've got how many letters? We've got 1, 2, 3, 4, 5, 6. 6 letters. They are all different. So this is just how would we permutate 6 different items 6 different ways? How we could rearrange this? How many different ways? Since order is important, it's a permutation. There's 6 letters. They're all different. So that's just a 6 permutate 6. And on the calculator, we do that with, oh no, we don't shift. Let's see. Let's just clear it. Okay. We go to the math key. We go over to probability, NCR, NPR, right? And some of you need to enter the 6 first and then call up this operation. But it should look something similar to this. We hit enter, that's going to be 720. That's all there is to it. You could use the formulas, but that's what's built into that operation. I'm going to focus on using the calculator because as we get larger and larger, that's really the preferred method I'd like you to see, using the calculator. We come to the next word. Again, each of these will be a little different. There are 1, 2, 3, 4, 5, 6, 7, 8. 8 letters in total. It's a permutation, but now we've also got some repeating letters. We have 2 E's. See, L is, there's 1 P, H, A, N, T. So that's there's just those 2 letters. So in this case, we're going to start off with the E's we treat, because there's 2 of them. We can't tell if this one's the first one, this one's the second. We could swap them, it would still be elephant. So you could see how you could swap the E's, and that's not a different arrangement. So the fact that we're double counting that, we're going to use the combination part. So we'll start with at the very beginning. We'll do this. You could probably do it later, but this is the way that seems to work best. Out of the 8 letters, we're going to choose 2 of them. That's these 2 E's. And so we're not saying that they're always at the beginning or anything, but this is the way we're going to count it. And then we're going to multiply it by the remaining letters, which are all different, using a permutation. So 8, we've used up 2, so that means there's 6 left, and they're all different. So we are going to permutate them 6 ways. So we'll see that we already calculated that. That's 720 times whatever this is. But again, with the calculator, I would just calculate them right in a row. Math, probability, NCR, we'll do 8. 8, choose 2. That's how that one's read. Times 6 permutate 6. So I'll put the 6 first, which you can do. Some of us don't have to, depending upon how like this one, we could do it second, but why not? See, poked up a 6, choose 6, and then I'll go ahead and do that. And that's really 720 times whatever this is. You could do them individually and then multiply them. Whatever works for you is fine. So this is 20,160. That's how many different sequences you could make. And finally, excellence. It's going to be the same process, but we first count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 letters total. And then we count repeats. There's 1, these E's. There's 4 E's. Wow, a lot of them. And again, we could, if you switch this one with this one, you wouldn't be able to tell the difference, right? So that part's going to be a combination. There's only 1 X, there's only 1 C, there's 2 L's. So we need to take that into account. There's 2 C's. There's a here. So, and I'll just show you. It doesn't really matter which order we take them in, but we have to sort of address these first as combinations, and then the remaining letters will be a permutation. So I'll just start off with, we're going to take a combination out of the 10 letters. We'll use the 4 E's. We'll arrange those in some places, and this is how many ways we can do that. In the remaining place, so there's now only 10 minus 4. There's only 6 letters left. We'll use these 2 L's. So I'll just put a little, I'm counting my E's. This is counting the L's. We're going to do 2 of those, right? 2 L's combined that way. We've chosen the L's, so that we're down to 6 minus 2 is 4 letters left. And that's going to be the C's. So we're going to use 2 of those. And then finally, that leaves 2. So out of those 2, we're going to do a permutation of those 2, the remaining. And that would be the X and the N. So if we multiply all this together, then we get the correct answer. And again, I wish there was a easier way to just pull it up. Some calculators actually have a little key. This one, we've got so many things that this calculator can do that they didn't assign it to a key. Fortunately, we don't have to do a second, and this will be 6 and come back down here 2, arrow up, multiply, math. Actually, I think there might be a way to assign this to a key, but she's just rambling here a little bit while I do all this. And then that's a P of 2P2. So that's times 2 permutation of 2. So we've got it all down. We'll hit enter. That's 37,800 is the answer for that one. That's how many the different ways. I've shown my work. That's good. Again, you could use the formulas that the book shows. We see we've got the correct answers for all of these, but you'll find, I believe, that using the calculator version with these combinations and permutations allows you to focus on what the problem is really dealing with rather than on the formulas. So that was question 18.